Hi, today I will be talking about effect modification. So in my previous video, we discussed this example. We were trying to answer the question if eating bananas was associated with lung cancer and if that association was confounded by smoking status. And I said that one of the ways to assess this would be a stratified approach, which is banana eating lung cancer association in smokers exclusively, and banana eating lung cancer association in non-smokers. And then it could be reweighted back using the Mantel-Hansel procedure to get the association for the overall group. But what if these two are significantly different? Then a different form of question arises. A different situation arises, which is the banana lung cancer association is now different, or the effect of banana eating is modified based on the levels of the third variable, which is smoking. So now we have modified the question that we ask in that situation, which is the effect or the association between banana eating and lung cancer modified by smoking status? So in effect modification, we must remember that we can evaluate it either using stratified analyses or joint distributions, and we can evaluate it on additive and multiplicative scales. For the rest of this video, I'm going to change to a more intuitive and a real life example. So now we are going to see is the effect between smoking and cardiovascular disease modified by sex? So here is our situation. We follow 100 non-smokers and 100 smokers, out of which 30 develop cardiovascular disease in the non-smoker group and 60 develop cardiovascular disease in the smoking group. These are measure of occurrence. For the measure of effect, on the additive scale, we take a mere difference, which is 60 minus 30, and the measure of effect on a ratio scale is 2, which is 60 divided by 30. So that's the risk, which is smokers are twice at risk of getting cardiovascular disease as are non-smokers. But this is still considering only the two main variables, which is cardiovascular disease and smoking status. Let's introduce the third variable, which is sex. As we can see in the measure of effect on the additive scale, there seems to be an effect modification, which is the effect of smoking on cardiovascular disease is different or modified by males and females. So the measure of effect on additive scale in females is just 10, which is the difference is 10, and the difference in males is 20. So we can see that the effect is being modified based on whether or not you're male or female, or the third variable. But in this case, we see that the ratio is still the same, which is the measure of effect on the ratio scale is still the same. If these numbers are not very intuitive, we can take a look at the plot. So on the x-axis is the smoking status, the 1 are the non-smokers and the 2 are the smokers. And we can see that the blue line represents the females. So there are 10 females who are detected with cardiovascular disease who are in the non-smoker group, and then there are 20 females who are smokers and had cardiovascular disease. And same is the orange line for males, and we can see that there are differences, or the effect is being modified. The males are higher than the females. So here we would say that there is interaction or effect modification only on additive scale but not on the multiplicative scale, because the ratios are still the same. This is yet another way to present the information depicted in the table and the plot in the previous slide. So as you can see, if in the female category, if people start smoking or go from non-smokers to being smokers, the number of cases will double. And the same thing follows in males, which is if the people start smoking or go from non-smoking status to smoking status, the number of cases will double. So let's continue with the same example. So we are trying to still explore the association between smoking and cardiovascular disease, and we can see that overall the association is still remaining the same, meaning the smoker group is twice at risk of developing cardiovascular disease than our non-smokers. But let's see what happens when we stratify by sex. Now, if you observe in the fourth column, which is measure of effect on the additive scale or the risk difference, it's different between males and females. So the effect of smoking on cardiovascular disease is modified by sex, which is males and females, but on the additive scale, but also on the ratio scale depicted in the last column. This can also be viewed on the graph on the right, and now you can see that the orange line representing the males is a little more far than the blue line on the bottom representing females if you compare it with my previous slides. This is interaction on both additive and multiplicative scale because, as you can see in column 3 and column 4 of the stratified analyses, the measure of effect on additive and ratio scale are different between males and females, meaning the effect of smoking on cardiovascular disease is modified between males and females on both additive scale and the multiplicative scale. This is yet another way to see what we saw on the last slide. So as you can see in the female category, going from non-smokers to smokers increases the number of cases, although not twice, but it does increase the number of cases. And in the male category, as you can see, going from non-smokers to smokers now increases the number of cases probably more than twice. So as you can see, or as you can compare to 2 slides before, the situation is really different. So now I'm going to depict the previous examples in yet another way to provide a stronger intuition. The panel on the left depicts the first example, which had effect modification only on additive scale, while the one on the right corresponds to the second example, which had effect modification on both scales. One way to look at this is going from non-smoking to smoking status. How does the risk increase? On the left panel, we see that the risk jumps twice in both males and females. On the right panel, we see that the risk jumps 1.75 times for females and 2.1 times for males. Another way to look at this is to go from smoking to non-smoking, which is in the reverse direction. Under this class of thinking, the table shows reduction in numbers, also known as attributable risk. On the panel in the left, we see that if people's smoking habit was taken away, then 10 cases in the females and 20 cases in the males will be curtailed, or a 50% reduction of the smoker cases in both males and females. But for the panel on the right, we may curtail 6 cases in females and 24 cases in males if smoking was taken away, leading to a 42% and a 52% reduction of smoker cases in females and males respectively. This has an important public health implication. So if I had funds, I would probably give equal amounts to either sex to curb their smoking on the left panel, but on the right side, evidently, I would give more funding towards males than females. There is an extended discussion of this slide at the end, which will dive even deeper into these numbers. So stay tuned with me if you want to find out more. So now we arrive at the second way to assess effect modification, which is the joint approach. The previous 2 examples that we saw assessed effect modification using the stratified method on both scales, meaning every level of the second exposure, in our example the males and females, had their own reference group. But in the joint approach, we will just have one reference group. So the table that you currently see is the measure of occurrence, and then we will formulate any one group as doubly unexposed or the reference, In my example, it's the female non-smokers who are doubly unexposed or reference, and we calculate the measure of effect as shown in the table below. So in the previous examples, we saw this plot, and we saw that the blue line, which is the females, and the orange line, which is the males, each had their reference group, which is denoted by 1 on the x-axis. But now in the joint approach, we just have one reference group, which is non-smoker females. To assess effect modification on additive and multiplicative scale using the joint approach, this is the formula that we would apply. And applying that formula to the numbers that we have, we saw that the female smokers, which is the 5.75, is greater than the additive scale or greater than additive effects, and also the 5.75 being greater than 4.81 indicates effect modification on multiplicative scale. Thus, matching the previous conclusion is that this example has effect modification on both additive and multiplicative scales. So now let's get into the extended discussion. So coming back to this discussion, I want to introduce yet another way to look at this data. I am just showing the right panel from that previous slide. Applying the risk jump in females of 1.75 times in the males, we should have seen only 39 cases in that orange bar on the far right. But what we see is 46, an excess of 7 cases. In the reverse engineering mode, let's apply the 42% attributable risk in females to the male group. Then in that orange bar on the far right, a 42% reduction of those 46 cases would get us to 26. But what we see in the male group, non-smokers, is only 22 cases, a deficit of 4 cases. So what is happening here? What are these excess or deficit cases? Why did we see the higher jump in male smokers? The situations I explained were if the numbers from females were applied to males, just like in example 1. In that situation, the jumps in the risk were the same, but the males were just proportionally higher. But now, because these are males and are smokers, we see that excess. Conversely, going from smoking to non-smoking, because those are males and are now non-smokers, we see that deeper deficit. So since it's dependent on both factors, these are the synergistic responders. Thus, effect modification on a multiplicative scale can be read as a proof that there are synergistic responders in our dataset. Finally, I want to make this clarification that in this presentation I have used interaction and effect modification interchangeably sometimes, but in fact these are two distinct concepts. So I would urge you to visit this paper by Tyler Vanderweel. Thank you so much.